Good evening. My name is Richie Hunter, and I'm the Vice President for Strategic Communications and External Relations at Rensselaer. It's my distinct pleasure to introduce you to the 18th President of Rensselaer Polytechnic Institute, the Honorable Shirley Ann Jackson.
Thank you. Well, good evening and welcome everyone to Rensselaer Polytechnic Institute. We are very delighted to be hosting this event tonight in conjunction with the National Science and Technology Medals Foundation, considering the question, are we going to Mars? And we're very delighted to welcome, who will be introduced again, Dr. Ellen Ochoa, the 11th Director of the Johnson Space Center, and a veteran astronaut. Welcome, Ellen. We're also honored to have with us Rear Admiral Thomas Zelibor, retired from the United States Navy, and we have a great tradition with the Navy here. Admiral Zelibor is currently the CEO of the Space Foundation, and we are delighted to welcome as well our moderator, Mr. Robert Altman, President and CEO of WMHT. But of course, I'm especially happy to be and delighted that joining us again at Rensselaer is fellow National Medal of Science honoree, fellow member of the President's Council of Advisors on Science and Technology, my former student at MIT, and my dear friend, Dr. Sylvester James Gates Jr., who is the Ford Foundation Professor of Physics at Brown University. Now, at Rensselaer, we have a rather audacious motto: why not change the world? So when we consider a question such as, are we going to Mars, the answer in this community is sure to be a resounding yes. But of course, not everyone may share that confidence, but at Rensselaer, we have a 6-decade history now of making the impossible possible when it comes to space exploration. I'm sure many of you know of George M. Lowe of the Rensselaer classes of 1948 and 1950, who was the 14th president of Rensselaer Polytechnic Institute. And in fact, he was on the planning team for the founding of NASA. And in his nearly 27 years with NASA, he helped to direct the Mercury and the Gemini programs. And after a tragic fire in an Apollo command module killed 3 astronauts, Mr. Lowe was in fact asked to take charge of the Apollo program and to oversee the redesign of the spacecraft and to land astronauts on the moon. And as you know, he succeeded. We also have educated a number of astronauts, including Jack Swigert of the Rensselaer class of 1965, who was part of the ill-fated Apollo 13 crew that was 200,000 miles from Earth when an oxygen tank blew up. And he and his crew members cool-headedly improvised and managed to return safely to Earth. And more recently, Rick Mastracchio of the class of 1987, one of the most experienced spacewalkers in history, and Reed Wiseman of the class of 1997 served aboard the International Space Station. And much as we love space explorers, the Rensselaer history in space encompasses engineering and research. For example, Dr. Michael Meyer of the class of 1974 is NASA lead scientist for Mars exploration. And so many of our alumni and alumnae have always been involved in space and have contributed as well to the engineering for the robotic missions to Mars, including to the Spirit, Opportunity, and Curiosity rovers, such as senior engineers Kobe Boykins of the class of 1996 and Frederick Sericchio of the class of 1994. And then we even have Mr. Dennis Tito, who is a very wealthy man, whose inspiration Mars Foundation has hoped to launch a privately funded crew flyby of Mars in 2018. And he's a Rensselaer alumnus, and he's the one who famously paid $20 million to go up to the International Space Station on a Russian Soyuz rocket. So we cover the waterfront. And a number of our faculty members and students, in fact, are doing pioneering scientific and engineering research that will inform space explorations going forward, whether they're studying microbes in Mars analog conditions, modeling ways to deorbit space debris, which is a serious problem, or forwarding image-based spacecraft navigation. And so this evening, as we consider the possibilities of the future, we know that it is up to humanity to be up to the challenge of setting foot on Mars. And the fundamental question is, are we going and how? And so you who are our students are likely to provide the actual rather than the speculative answers to those questions. So please ask lots of questions of us tonight. And we hope that you will find the conversation inspiring. So let me thank all of you for coming. And as you know, we build bridges to the future. We have a history with infrastructure. We've built bridges to space, and we've built bridges to the digital world that we live in. And one of those pioneers is with us this evening, our own trustee, Mr. Curtis R. Priam, for whom this facility is named, as you know. And Curtis was a founder of NVIDIA because he invented the original graphics processor on which the company was founded. So Curtis, why don't you stand and be recognized? And his wife, Cindy, is with us, and thank you for being here. And I'll do one more introduction. My mother always said, if you start, you can't ever finish. I want to introduce our own trustee as well, Dr. Janet Rutledge, herself of Rensselaer Law. Thank you very much.
Andy Rothman Noonan is the executive director of the National Science and Technology Medals Foundation. Under his leadership and with the help of his talented staff, the foundation has reinvigorated its mission to honor recipients of the National Medal of Science and the National Medal of Technology and Innovation. The very scientists and technologists responsible for countless life-saving and life-changing discoveries. Andy believes that science and technological advancement enables positive sweeping change, and the people responsible for these amazing leaps forward should be honored and their personal stories shared broadly. Andy serves on the board of the Rothman Family Foundation, Trinity College's Board of Fellows, and he is a member of the National Academy of Inventors Advisory Committee. Andy is a graduate of Trinity College, where he received a bachelor's degree in philosophy. He's committed to creating opportunities for students to be inspired by scientists. And although he's not a scientist himself, he is both humbled and inspired by the STEM community's relentless pursuit of solutions to the world's most challenging problems. Andy?
She started talking. I didn't know she was talking about me there for a second. As Richie mentioned, and thank you for that. It was very nice. My name is Andy Rothman Noonan. I'm the executive director of the National Science and Technology Medals Foundation. We could not be more pleased to be partnering here with RPI, and this venue is absolutely gorgeous. So thank you again to leadership and faculty at RPI for making this happen. I wanted to thank our sponsors real quick, the National Science Foundation, the Howard Hughes Medical Institute, and the United States Patent and Trademark Office. Without them, these things aren't free, and we aren't able to provide access to these incredible individuals like we have here tonight. Most importantly, though, we also want to make sure that we can engage with an incredible group of students that we have here tonight, so thank you all for coming. Tonight, as Dr. Jackson covered, we're going to discuss not only the possibility of space travel to Mars and tackling interplanetary and interstellar travel, but we're going to explore the lives of who these individuals are on stage. To say that their narratives are impressive, I think would be a bit of an understatement, but don't let that intimidate you. They've all overcome They've all struggled. They've all had to deal with failures. And they all have decided to continue the pursuit of knowledge in order to accomplish their goals. So it's not only a celebration of scientific and technological achievement tonight in science and exploring sort of the great unknown and what's beyond. It's about access and engagement. You're going to get to hear from a various number of people on various different skill sets, various different disciplines. They're going to have different insights, and they're going to have different points of view. And then the panel members are going to turn to all of you and want you to ask them questions. So take them up on that offer. I think you're going to find that these questions you're going to ask are probably going to have some interesting answers. Tonight is an evening with program. This event tonight is a discussion. It's an opportunity for all of you to collectively understand how advancements in science and technology has challenged us to dream big and go above and beyond. So I wanted to first announce who will be leading our discussion tonight and ask him to join us on stage, President of WMHT, Robert Altman. Our first member of the panel tonight is President of Rensselaer Polytechnic Institute, Dr. Shirley Ann Jackson. We have former director of the Johnson Space Center, Dr. Ellen Ochoa. Brown University's Ford Foundation Professor of Physics, Dr. Jim Gates. And last but not least, Chief Executive Officer of the Space Foundation, Rear Admiral Thomas Zelibor. All right, Robert, take it away.
Good evening, everyone. Thanks for coming. I thought we could begin by letting you know a little bit more about our very, very distinguished panel this evening before we launch into our conversation. On my right, Dr. Shirley Ann Jackson, who you all, I'm sure, know well, who currently serves as the 18th president of Rensselaer Polytechnic Institute. She was the first African-American woman to receive a PhD from MIT, chair the Nuclear Regulatory Commission, lead a top-ranked U.S. research university, and win the National Medal of Science. Outside of RPI, she serves on several boards, including FedEx, IBM, and Medtronic, and was previously appointed to the President's Council of Advisors on Science and Technology and the President's Intelligence Advisory Board. Dr. Jackson's an International Fellow of the British Royal Academy of Engineering, a member of the United National Academy of Engineering, the American Philosophical Society, and a Fellow of the American Academy of Arts and Sciences, the American Physical Society, and the American Association for the Advancement of Science, of which she also served as past president. She holds 53 honorary doctoral degrees.
Oh my gosh.
Dr. Ellen Ochoa, a veteran astronaut, was the 11th director of the Johnson Space Center. Ochoa joined NASA in 1988 as a research engineer at Ames Research Center and moved to the Johnson Space Center in 1990 when she was selected as an astronaut. She became the first Hispanic woman to go to space when she served on the 9-day STS-56 mission aboard the Space Shuttle Discovery in 1993. She's flown in space 4 times, including STS-66, 96, and 110, logging nearly 1,000 hours in orbit. Congratulations. Dr. Sylvester James Gates, professor of physics and co-director of the Presidential Scholars Program at Brown University. He received his PhD from MIT. His doctoral thesis was the first at MIT on the topic of supersymmetry. He was a University Systems Regents Professor, Distinguished University Professor, the John S. Toll Professor of Physics, and Center for Particle and String Theory Director at the University of Maryland, College Park. He also served on President Barack Obama's Council of Advisors on Science and Technology and the Maryland State Board of Education. Dr. Gates is past president of the National Society of Black Physicists. He's a fellow of the American Physical Society, the American Association for the Advancement of Science, and the Institute of Physics in the United Kingdom. His current work focuses on a combination of theoretical physics, mathematics, network theory, computer science, and even evolution and genetics. Thomas Zelibor is Chief Executive Officer of the Space Foundation, an organization dedicated to inspiring, educating, and connecting, advocating on behalf of the global space community. Before joining the Space Foundation, Mr. Zelibor was Chairman and Chief Executive Officer for Lightwave Logic Incorporated. He received his Bachelor of Science degree in Oceanography from the United States Naval Academy and was a naval aviator early in his Navy career before branching out into space and information technology assignments. So as you can tell, we've got quite a remarkable group with a remarkably diverse set of backgrounds. Let me just for a moment tell you what we're going to try and cover tonight. We're going to talk about why Mars, why we're so fascinated by the red planet. We're going to talk about why explore at all. We're going to talk about why we do it, what the impediments, the challenges are that need to be overcome, the technological challenges, the human challenges, and the like, what the mitigating factors are that are going to enable us to overcome them, what the business and political climate is for space exploration right now, and of course, arrive at the ultimate question of, are we going to Mars? I hope it should be a fascinating time prior to your questions, of course, which will help guide us toward our ultimate conclusion, if there is one. I'd like to start, though, with the panel by asking each of you, Mars is a special place in all of our histories. I'm curious when the red planet was first on your human radar as you were growing up.
You're looking at me, I see.
Okay, well, you're on my right.
Okay. So first of all, good evening to the audience. I'm very happy to be here, very honored to be among this distinguished panel. There are actually two places where Mars sort of entered my life early. First of all, I decided I wanted to become a scientist when I was about 4 years old. And now I'm 68, so I'm still trying to do that. But the truth of the matter is that I became a science fiction fan very early in life. And for me, there were two places where Mars intersected my life very early. One of them was on a television show by Walt Disney. They had this series called Man in Space, and the final, it was a 3-program show, and the final show was how we were going to get to Mars. And they were showing animations of ion-driven, atomic-powered spaceship, and that's how they concluded that we were going to get to Mars, which to me was just fascinating. And then the other intersection came from my science fiction reading. There's a very famous science fiction author by the name of Isaac Asimov, but he also had pseudonyms. And in the middle 50s, he actually wrote, for children, a series of books about a character named Lucky Star. Lucky Star, Space Ranger. And one of those adventures of Lucky Star was on Mars, and I remember getting a book with this vehicle with these big balloon tires that were necessary to navigate the sands of Mars. So those are the earliest memories I have in my life of encountering Mars.
Dr. Jackson?
Well, for me, my encounter with Mars actually came from the moon first, because I'm truly a child of the space age and the space race, because I grew up in the period when the first artificial satellite was launched, the Sputnik 1. And that really riveted the nation's attention on math and science, and it was followed about 4 years later by the Russian launching of man into space, Yuri Gagarin. And so that, kind of turned my attention outward. My father used to I grew up in Washington, D.C., and my father would take us, his children, down to the mall, and in those days there were rockets out in front of the Smithsonian. And so as I would go into the Smithsonian and spent a lot of time, then I got more interested in what was beyond the moon. And then I got into science and math because of a focus on that, and I ended up in an accelerated program, and then the rest is history, as they say.
Dr. Ochoa?
Well, I really got interested in Mars because of actually working at NASA and what we're doing there in terms of trying to get us there. So I think I should go back earlier and just how I got interested in space, just to begin with, because I didn't start out thinking about space or science when I was young. Of course, I grew up in the Apollo era as well, and everybody in the country was watching, but there weren't any women astronauts at that time, and so it just never entered my consciousness of being an astronaut or even working in the space program at that point. I didn't know any scientists and engineers. So when I went off to college, I thought I was either going to be a music major or a business major. Kind of moved out of those, tried various different things, and really through my math classes got interested in science. Because everybody else in the calculus classes were, they were studying engineering or physics or something like that. So I thought I should go check them out. So it wasn't really till I was about a couple years into college that I even moved into the sciences at all. And then I had a chance in some summer jobs to do research and got interested in the idea of becoming a research engineer. Well, my first year in graduate school is when the space shuttle flew for the first time. And that was a big deal for a couple of reasons. It was a very different kind of spacecraft than I had ever flown before, and a lot of what it was going to do in space was science experiments. So being a scientist or a research engineer, here was this laboratory in a very unique environment. And so the thought of being able to do research in space was really interesting to me. And because it had all this capability, NASA had really opened up who they were looking for as astronauts. And so, while they were still selecting test pilots, they were also selecting scientists and engineers and medical doctors. And the first group of astronauts selected specifically for the space shuttle program, it was announced in 1978, and I was an undergrad. And it was the first class that included women and minority astronauts. And that was partly because of the capabilities of the shuttle itself, and partly because of what was going on in the country at that time with equal rights and, really trying to open up careers for women and minorities that hadn't been opened before. So those things sort of all coalesced to me really wanting to be part of the space program and specifically looking at the astronaut corps. And then we'll talk more later about how I was able to work on going to Mars and what we're doing now at NASA.
I'm going to be much more basic than the rest of the panelists, I'm sure, in a lot of ways. I'm outgunned from the academic side, but I do have a PhD in the School of Hard Knocks. I also grew up during the era of Apollo and Gemini, and it was I thought it was fascinating, to grow up in the 50s and see that going on. But when I say I was a little more basic, instead of having these big aspirations of going to Mars, I watched shows like Buck Rogers and Flash Gordon, and I thought it would really be cool to fly around them with a big silver tube up. And instead, I ended up flying F-14s instead. So, but but as I got, I'll call it more experienced, I started looking at the opportunities that space exploration can bring, and the competitive advantage it can bring to a country like the United States in promoting STEM education and building the next generation workforce. And so when I got more senior in the Navy, I was very heavily focused on the IT into the space program. I ended up running the Navy space program for several years, and so it fascinated me, and now I'm back into that world and loving every minute of it. So,
Bob, if I could make
Sure.
one comment, because I was reminded of something from what you said, Ellen. Actually, I was they tried to recruit me into the astronaut program early on, and in fact, who they sent to talk with a group of us, women and minorities, was Nichelle Nicole.
Oh, yeah.
Remember, she was the one on Star Trek.
Mm-hmm.
And
Lieutenant Uhuru.
yeah, right, Lieutenant Uhuru. It didn't work, but but she tried. And then one of my very best friends, whom you may have known, was Ron McNair. And he was on the Space Shuttle Challenger and lost his life, but he was a believer.
And since Shirley's revealing, I guess I should do a reveal also. So I got interested in science because of space at age 4. But I also applied to the astronaut corps. And the person who tried to recruit me was Ronald McNair.
I've talked to a lot of people who mention Ron.
Yes, but as I was leaving Harvard and about to go to Caltech, I got a call from NASA saying I had the wrong stuff. So I was forced to go to Caltech and work with this guy named Richard Feynman, and this other guy, this other guy, Murray Gell-Mann. So it kind of worked out.
It worked out all right.
So Mars has got this special place in our kind of cultural history. Does it have the right stuff for us as a place we ought to be going? Is it the logical next step?
Well, maybe I'll talk a little bit from a science and exploration perspective, but I think there's lots of different perspectives you can talk from. But yeah, I mean, Mars is interesting to us for a variety of reasons, but partly because it seems to have all the ingredients, or have had all the ingredients, to have been habitable at some point. And the more we learn, the more that seems to be the case. So that's really interesting to scientists, as well as I think maybe lots of other people. We want to understand if there was life on Mars at some point, and we also want to understand more about what are those characteristics that bring about life. And so we know early in Mars history, it had a magnetic field, it had an atmosphere, it had liquid water. That's right. Those were things we didn't know a while ago, and we know now. But fairly early on, as it cooled, it lost its magnetic field, and then the solar wind stripped away the atmosphere, and then it was too cold and didn't have enough atmosphere to really support liquid water. But it had all those ingredients, and so we really want to go and be able to find out for ourselves more about, the history of Mars. See if we can understand whether or not there was ever life there, but also understand, hey, where might our own planet be headed way in the future, given these massive changes happen to planet Mars.
And Mars, to me, is also interesting because it doesn't have tectonic plates, and so a lot of the history is still embedded in the planet. And Ellen mentioned the solar wind stripping Mars of its atmosphere. And I think we're still understanding more about the magnetohydrodynamics of the solar wind and how it affects our weather and our atmosphere. And so if we can go back and understand that, as Ellen said, it'll help us hopefully to project forward about what could happen here.
But there's a romantic aspect to this that none of us should lose track of, because Mars, of all of our sister planets, Mars is the one that has had the most impact on our culture the last several hundred years as a place to go and think about. And to me, a few years ago, I guess it was 2014, I was asked by the New York Times to pick out the most prescient science fiction movie I had seen. And I picked The Martian. And the reasons were, first of all, the accurate depiction of how science works, how you work a problem. And then the culture of NASA was so well embedded in that movie that I could not just, I couldn't overlook that. But on the romance part, my comment was, Mars is the next great questing adventure for our species. And I really and genuinely believe that it is the next great outward questing adventure that humanity will engage.
And we had talked earlier about the book, The Martian, because I actually invited the author out to Johnson Space Center after the book came out, because so many of our folks had read it. And what he was really able to capture is both the science and the engineering of how you do exploration. Right. So, you have this astronaut trapped on Mars, and both he and the people on the ground they're going through this thought process that we do all the time at NASA, which is, okay, what's the first thing that's going to kill me? And how do I figure out getting out of that? And then what's the next thing that's going to kill me? And how do I attack that problem? And then what's the next thing? And so the whole process of sort of how you figure out, prioritize the issue, the situation that you're in, and start to problem solve. I mean, it was so familiar. You could read the book and you could actually practically put people's names to these fictional characters, because it was so familiar, and I think that was one reason so many people at NASA really enjoyed that book.
So I think we answered the question of why Mars, because Mars does hold that special interest.
Well, you can see it too.
And you can see it. But I guess the larger question, Tom, you started answering this about why this kind of exploration at all, not just Mars, but you talked about competitive advantage. What are the other reasons why we're doing this?
Right. My real question is why not? Okay, not why should we, but why not?
That's what we say.
Because whether, in my opinion, whether it is successful or achievable or not, when you start looking at the technologies that are going to have to be developed in order to sustain life on Mars, we're not going to just go up there and touch base and come back. I mean, it's at least a 6-month trip each way. So we're going to want, the astronauts to stay there for a while. But the technologies, whether it's medical advancements, whether it's robotics, sustaining life in an austere environment for a long time, which is, creating, opportunity, how do you grow food that will sustain the astronauts for, it's going to be at least a year or more, right? And then, how do you create water? All of those technologies will benefit us here on Earth, okay? Because, I think, Ellen is absolutely right. We would be naive to think that we're not changing, over the life of our planet, just like other, planets have changed. So I look at it as a from a business perspective, that there's going to be a lot of technologies that are going to be developed, but I looked at it from the more, how can it benefit humanity on Earth too?
Well, I actually think about it as well, and Ellen knows much more about this than I, but just getting there. So you got to get there.
Right.
and having people live in such a confined space for so long. Mm-hmm. The whole thing of exposure to radiation in space, and for a much more extended time than astronauts have spent heretofore. But what's also fascinating to me is the opportunity to learn from other fields. So, for instance, you were a naval aviator, but I've spent a little time on some of the Navy ships, including the submarines. Mm-hmm. And to me, there's some things that one can learn in a couple of different arenas. One having to do with how do you produce oxygen. Secondly, water. Third, what effects psychologically do you have on people living in such a confined space? And so those sorts of things are what happens to the circadian rhythm. And we do work here in terms of looking at the circadian cycle and what does light, how does light and darkness affect that, and neurological and cognitive functions, all those things. But there's work from other fields that I think have implications, but I don't know, Ellen.
Yeah, so all of those things are important, and one of the main reasons we have the International Space Station, we use it for a variety of different things, but for many of those issues, the International Space Station, ISS, is a great test bed for understanding, especially human health and performance, and what it means for going to Mars. So we kind of categorize the risks for human health and performance kind of in 5 main areas. So radiation's one, isolation, distance from Earth and what that implies, the gravity environment or the microgravity environment, and then the actual environment in the spacecraft, which is talking about clean water, clean air, and all that. So you talked a little bit about the isolation, and of course, a couple years ago, we had one of our astronauts, Scott Kelly, who stayed a year on the space station. Our normal missions are 6 months long, and a cosmonaut, Mikhail Kornienko, also stayed up a year. And I know when Scott came back, people would ask him, kind of, a year, what was that like? And he said, well, let me put it this way. If a doctor told me tomorrow that I only had a year to live, my first thought would be, well, that's a pretty long time. So you know, there certainly are implications for being in this remote and, you know, hazardous environment. And a trip to Mars, in general, the way that we're envisioning it at NASA, would probably be between 2 and 3 years. And so that is certainly one of the things that you have to deal with, and, you know, the sleep cycles and the light. And those are things that we actively engage in research on the International Space Station, as well as all those areas.
So as we're talking about the challenges here that need to be overcome, we can talk about the human challenges. We've introduced them. What's the toughest one among what's the limiting factor here as we look towards a potential mission to Mars?
So there's a variety of things. We are concerned about the radiation,
yeah.
But I don't think there's anything that's insurmountable at all, and we're learning a lot in a variety of different areas. So the problem with the radiation is really the galactic cosmic rays and the fact that you're getting this constant dose the entire time, really, that you're on this mission. So one of the things is, you know, it increases your risk for cancer, right. But they're also concerned about other things like affecting your cognitive ability actually even before the mission ends, and other types of diseases like cardiovascular disease that are radiation induced. But you know, we're looking at, is it possible to do magnetic shielding? A lot of the deleterious effects are caused by inflammation, and so can you take medication that reduces the inflammation? And we've even found from patients who receive radiation as part of, you know, cancer therapy, there are some people that just aren't as bothered by it. So there's a genetic factor too, and it may be in the future that once we learn a little bit more about that, that has something to do with how we select people, you know, who aren't as susceptible as others. So, you know, there's all these threads that we're trying to understand more about.
So you ask about insurmountable barriers. Actually, we're the most barrier that I worry about most strongly. The physical limitations in terms of radiation, time, energy, what it takes to get there, you know, these are things that NASA is expert at solving. But for me, the more serious problem is whether, as a society, we're going to decide to do this. That, to me, is the greatest problem. So the question is, are we going to Mars? To me, that's the same question as, are we going into the future? The answer is yes, we're going to go to Mars. To my mind, the only question is, when are we going to actually go? And on that question, I fear that I'm rather more pessimistic than most people, because I'm confident that we're going to surmount the technical challenges, but this is going to be happening in a time frame where globally our society is going to be in turmoil. This is going to be political, it's going to be sociological, and it's really going to ask the question. So let me give an example. So let's go back to the glory days of NASA going to the moon. I was a child, like all of our parents. We were children watching that and fascinated by it. This country spent about 5% of its annual budget for 10 years to get us there. And I checked with some friends earlier today. The budget for NASA right now is 1/10 of that number, or approximately, maybe within a factor of 2, 1/10. So if you reduce the resources in the premier agency that got us to the moon by a factor of 10, and then you say we're going to be there in, 18 years? That calculation doesn't work. I'm a physicist, I do calculations all the time. That calculation doesn't work. So we're gonna be challenged with creating a new paradigm for allowing this to happen. And one of them, which many of us look to, is public-private partnerships. I'm a science fiction fan, and so, you know, I watch movies like Aliens and what have you. And particularly in Aliens, I'm fascinated by the repeated appearance of a corporation called Weyland-Yutani. And I don't know if people here watch this movie, but that corporation is not a good actor. But in real life, I think that it is probably going to be some kind of partnership between government and private business that will get us there. I just don't think it's going to be there by 2030.
I think probably everybody on this panel has some familiarity with public-private partnerships, so I want to make sure everybody has a chance to talk. But I will say that certainly NASA has moved in that direction over the last 10 years, quite a bit.
That's right.
And the driving factor really has been the International Space Station. And we use that for international collaborations as well as partnerships with companies here in the United States, including both established aerospace companies that everybody knows about, Boeing and Lockheed, as well as a lot of the newer ones, like SpaceX. And we have really changed our model in terms of how we work with companies now, where we are now buying services. We don't own the spacecraft. And we try to give companies, of course we have requirements, but we try to do them at a much higher level and give more opportunities for companies to decide exactly how they're going to meet those requirements, and also look for other customers. NASA's clearly still the anchor customer for human space exploration, and there's really not any other big customer out there, but there's the hope that it will grow, and these companies are looking to see what other customers there are. So we've really changed the model of how we work.
Yeah, I'm going to pile on to this because the two things that I thought would be potential stumbling blocks but are also opportunities are political will and financial capability. All right. So I totally agree with what you were saying, Jim, and that's that the public-private partnerships, I think, are going to be essential to that. In order for that to happen, some of the business models are going to have to change. Because right now you have the Elon Musks and the Jeff Bezos of the world that are trying to beat up on the, what I would call the military-industrial complex companies, the Lockheeds, the Boeings, the Northrop Grummans. And so we have to transition from a competitive environment to a cooperative environment, and where everybody has a piece of the pie, so to speak. So I really believe that can happen. For anybody that has been watching this lately, there was a ton of excitement back in the 50s and 60s, with all the going to the moon, and when President Kennedy said we're going to send a man to the moon, and it was done in 10 years, that's great. But I would say in the middle of the space program, which is something you experienced, it just became routine. Okay, and it's nothing even close to being routine. But I think the American public saw it that way because, okay, we launched shuttles up and down, and they're coming back and forth, and now I think we're all seeing that excitement again because you have these billionaires that are spending billions. And for anybody that watched the SpaceX launch, where both the boosters simultaneously landed, at Canaveral, and what I was watching was, the technological side of that was phenomenal, but I was watching the control center, for SpaceX, and it was full of millennials, and every stage of what was happening there, they were just going nuts. So there's young people energized by this. The entire world was watching it, and I think we need to take advantage of that and allow us to work. And then I'll shut up after I say something about the political side. The political will. Space is one thing that I think kind of crosses all the boundaries, and people don't really get partisan about whether we should go to space or not. So if having a goal of going to Mars, I think is something that can solidify us because there's so many other side benefits to it.
So Admiral, let me say the following. Here, being a university president, I'm not so, negative, but I want to make a couple of points. You mentioned the millennials, and we talk about public-private partnership. And I'm one who fundamentally comes from the point of view that what has advanced us is the three-legged stool. Government, industry, and universities.
Right.
Because we talk a lot as if we're talking in a vacuum, and if you don't have the human capital, you aren't going anywhere. And so, and it is because of the excitement of the next generations that I think will ultimately carry the day. The other is, you say, what is the greatest, challenge? you know, Ellen outlined Dr. Ochoa, but she knows how to call her.
Ellen's fine.
You can call me Shirley, please. So, you know, you outlined the various hazards, but in many ways, the real challenge from a technological and other point of view is that they are really intersecting challenges and vulnerabilities. But therein lies opportunity. You mentioned inflammation. Well, inflammation is implicated in so many diseases, and the things we can learn from that perspective. There are questions about how bacterial infections can propagate in weightless environments. And so there are things having to do with the development of new materials, because the only way, you're talking about shielding, and shielding is important. But if you're going to be, you know, riding along through space for 6 months, a year, whatever, and something is being bombarded by the cosmic rays, it is also going to be radiation damaged. And so the effectiveness of it has to, you know, you have to think about how does it last to go and come back. But therein lies opportunity. And if you think of it that way, the challenge is the opportunity, then it is an opportunity for science, it is an opportunity for engineering, and it is ultimately a commercial opportunity. And so that's how I really, that's the way I frame it. And so I think of threes, the three-legged stool and the opportunities in fundamental science, engineering, and business.
And this is going to have to happen in a period which is unlike any in human history, in recent human history, because climate change is going to challenge our society at an enormous level. It's going to be an enormous challenge.
So we have to go to where there's no climate, right?
Well, that's one solution, I'm sure. But
should we be thinking of this as a colonization opportunity?
Perhaps
that's a half-serious question.
No, perhaps we should.
We got to get the atmosphere back.
It would help.
But the fact is that the political will that we enjoyed in this country during the space race, which, you know, drew us all into the excitement, that political will was the only major threat in that period was from another nation, namely Russia. And in fact, that drove part of our space program, because the question, I remember hearing adults saying, do you want the Russians to be on the moon and not us, right? I mean, that was a question that was often asked in those days. Right. And so that partly drove the development. So as I look into the future and I worry about an era of trying to make this big dream happen, when I'm pretty sure climate change is going to be impacting us in an increasing manner, I worry about whether we will have the societal, it's not going to be just the politicians, the public is going to weigh in on this question. And so that worries me. And the other thing that, like I said, we're going to go. So it's not an if question for me, the question is time scale. There is, in fact, I think, another nation that I would prefer to think of as a competitor as opposed to an adversary, and that's the nation of China. Most Americans are not aware that China has a moon program. She has been following this course for over a decade. She has made a commitment to land a person on the moon. I don't remember hearing a particular number, but should she be successful, I think that will be our competitor if we're going to have a competitor. And I would hate to see that happen, because one of the great things about the movie The Martian is that we found out that we had cooperative fellow nations that helped us out. And that would make it much more easy for us as a species to actually make the journey.
Well, maybe there's a lesson with the space station, which is Russia did start out being our great, not just competitor, but adversary. Mm-hmm. But now you look at who cooperates, you know, in the space station. And if you look at science itself and how scientific research is done, it's very international activity. You look at the Large Hadron Collider. You look at CERN itself. You know, all of these things. So I'm not unrealistic, but I'm not pessimistic either.
Yeah, and I do like to point to the space station because I think it is a good model for international cooperation. So we've had these 15 main countries, and the Russian Space Agency, European, Canadian, Japanese, and the U.S. And we've been working cooperatively together for 25 years. And during that time, U.S.-Russia relationships have ebbed and flowed, right? Sometimes they've been very strong. Other times we go through periods where there's issues. But we've maintained a very, very solid partnership with the Russian Space Agency over those full 25 years. And I've had the opportunity to spend time in Russia and negotiate with members of the agency, and of course go over to Kazakhstan to see our cruise launch. And they are focused on helping to make the space station a success, and they see it as a way to do science in space, to continue the space exploration story of which Russia has played such a big part over the last 25 years. And it's really been a partnership where we have helped each other out during periods when one or the other space agency was dealing with an issue. And so I do hope to see that model continue going forward.
Did they plug the hole?
Yeah.
Yes.
So as we're going to wrap up and go to questions in a few minutes, but I'd like to see if any of you would like to speculate on what it is actually going to look like and when it's going to happen. I know you think it's not going to happen quickly, Dr. Gates, but what is realistic here on putting a manned mission to Mars?
A human mission.
A human mission.
Thank you.
Yes, let's get it right here.
Knew that was coming.
A human mission.
So that means Ellen has to answer.
Well, I'll start out, which is just to say we've, over many years, we've had a number of what we call design reference missions to Mars, where we say, okay, here's a way that you could do it. And we've looked at a variety of different things. And one of the things you have to grapple with immediately is, okay, there's really kind of only two choices. You're there for a couple weeks, or you're there for almost a year. And so you have to decide sort of, if you're going to actually land, which model you want to go with. And given that it takes, 7, 8, 9 months to get there, and the same amount going back, we've really kind of come up with, you really want to stay more than a couple weeks. You want to have a mission where when you land, you actually have that opportunity to be on Mars for a while. Now, we've looked at other design reference missions, some where you don't actually land. Maybe you go to one of the moons of Mars. Now, there's very little gravity there, so to say you actually land on them, it's more like you kind of dock up to them, and then you have to figure out how you actually work. Yeah. But you may want to operate telerobotically on Mars first before you actually attempt a human landing, so that's another way to do it. One of the things we've been asked to look at is, so what's kind of the quickest way you can get to Mars if you just want to send people sort of and maybe not land, and you can look at when the orbits line up the best, and you can get there maybe in about six months and then whiz around Mars and come back. But when you think about it, okay, so you're in the spacecraft still for more than a year. You go by Mars very quickly. Turns out it's dark, so you don't actually see it. And so you're really in the spacecraft for a year. You've gone to Mars, but you haven't actually done anything or seen it. I was like, that's not the mission I want to sign up for. I want to have some time there, whether it's on a moon or on Mars itself, or at least on orbit to get that better view, to understand how you might actually start to operate on Mars, or use the regolith to help create propellant or do something like that. So you're really starting that opportunity to understand what it would take to live on Mars.
Great.
Well, I think isn't it kind of a staging thing? I mean, here's a great opportunity to create some ambulatory robots that can operate on Mars, can do things to give you a sense, and ultimately can help you build a habitat. Because if you think that the idea is to stay there for a while, it would be nice to have some kind of quasi-habitat there, right? And so that can give you some thought about how you would stage out how long it would take to get there. And then I'm one who believes you do set a time frame. It may not work, but it forces people to go back from there to where you are, to think about what are all the challenges and tools that you need to, the challenges to overcome and the tools to develop to actually have a chance of getting there. But, of course, from the political will perspective, there's the disappointment factor, but I nonetheless think that you do that. But I'm one who says you stage it, and that in itself drives a lot of technological development.
One thing that I think, we can't forget, and that's our education system here in this country. Right now, we have 15% of our college graduates are in STEM-related fields, okay?
They're all here.
And that's, and
You're doing your part.
And we know that by 2023, 50% of all the jobs in this country are going to be STEM related. So if you can do the math, you're all smart RPI students, 50%.
Brilliant RPI.
Brilliant. 50% minus that 15, is, there's a big gap there. Where does that come from? It may come from other countries, and that's why I talked about the competitive advantage. 27% of the students that graduate from college are actually hired in the area that they studied in the universities. So when you look at that, and then you start comparing, okay, what do we need in order to excite this future workforce? Well, my guess is that the first astronauts to go to Mars are probably in grade school or middle school right now. And if they're not getting that exposure to STEM, to get them excited using space as the hook. And I'm not saying you have to be an astronaut, but we're, the engineers and the scientists and all the other STEM-related fields, the physicists. We need to really, I think we really need to, as a country, think about that and how we excite that future workforce. And that's the one thing that I worry about on this.
If I can I just have a comment? Thank you for bringing that up. Both Shirley and I spent a lot of time during the last presidential administration looking precisely at this set of issues, and the importance of STEM education is a very a thing to keep focused upon, but not just for technological advancement of our nation, but for the simple economic welfare of our citizens. Right. Because the work environment is rapidly changing. I like to point out to people that Budweiser beer has used a robotic truck to make a delivery. And so that's how fast the future is coming.
So with the thought of the robotic Clydesdale, I think we'll turn over we'll turn to our audience for their thoughts and questions. There are folks out there roving with microphones, and I think there's some fixed microphones up in the balcony. If you have a question.
I have a question.
Please wait for a microphone. Wait for a microphone.
This has been fabulous. I was so glad to hear you mention the Martian and aliens and how they relate to real life science and what you guys experience on a day-to-day basis. But my question is, okay, so we get to Mars. What does it look like a day in the life of being on Mars? So what do you do when you get up? What do you do, how do you function on Mars?
So when we get there, what's a day in the life on Mars going to look like?
We're all pointing to you.
Okay, well, anybody can speculate, so feel free for anybody to answer. But I hope it will be a combination of you are doing some actual science experiments on the planet, which is so exciting to scientists who, are planetary geologists, as well as you are understanding what it takes to actually live. Now, that doesn't necessarily mean we're going to go colonize it, but if we want to do work on the planet, we have to understand more about how are you actually supplying, the air and the water, and how are you making use of the resources. So I see part of the work being, there's probably some robots on the planet who are, gathering the regolith, and they're putting it into various pieces of machinery that are helping to create oxygen and water and things like that. And so it's partly sort of that aspect as well as the science aspect.
So you can make oxygen, you can make an atmosphere.
Yeah, in fact,
you can make oxygen. They do it in submarines, but it doesn't mean it's exactly the same process, but that happens.
Right, and in fact, so NASA has a science mission, the Mars 2020 lander that's going to land in 2020, and they do have an experiment on board which is going to take the carbon dioxide in the atmosphere and create oxygen from it. So that's really going to be our first opportunity to look at, how does that work? How does at least this one, initial experiment work? So that's something to look forward to in just a couple
years.
Well,
I'm going to go to my Pilates class.
Okay.
and then I'm going to see what my experiments are for the day.
So, since I'm a fundamental scientist, for me and my community, it's always about having the opportunity to look out there. And with the 2 moons, low gravity moons at Mars, one can imagine setting up amazing observatories to look out at the universe. And people know I kind of work on this thing called string theory. Whether it's real or not, we don't know. But I'm not Sheldon Cooper, I can tell you that. But the point is that such observational facilities on the moons of Mars would offer, I'm sorry?
And on Mars.
Well, I'm worried about the atmosphere there.
Well, so am I, but...
Okay. But on the moons, one can imagine just some amazing... So we have the Hubble Space Telescope here. Imagine a generation 3, 4 that orbiting one of the moons around Mars, looking for black hole physics. That's, to me, for my community, that's like the Holy Grail. We love that.
But you're not the only physicist on the panel.
Oh, right.
So
Okay.
What I'm thinking about is how you get there, the trajectories and the use of physics, Lagrange points, all of that. And I think that's an interesting exercise.
Another question?
Yeah.
Here we go.
So I guess my question is, especially the pessimist, what are your current views on the current ways to get to Mars, like the NASA SLS program or SpaceX's BFR?
So, to me, it's an energy problem. I mean, it all boils down to energy, because you're going to have to expend a certain amount of energy to get people there. And when you start looking at time versus the time it takes on the various options, I know NASA's working the problem. I have supreme confidence that they're going to find some solutions. But the thing that worries me is actually the radiation problem more than anything else. We talked about shielding, which is one possibility. We've had astronauts on long duration missions, and we've actually seen evidence of changes in genetic structure for those astronauts upon returning. And so it's not clear to me that that's going to be the big problem. And so that's my greatest pessimistic part, is that, look, if I had a starship, I could get you there in a few seconds, and then I'd say, we've got it done. And unless some kind of breakthrough technology like that appears, that's the source, that together with the radiation threat, those are the sources of my concern.
Ellen, this is perhaps not a positive question, but it relates to the young man's question. Has there ever been thought on NASA's part of sending animals?
So I haven't been part of those conversations, but I expect at some point in NASA's history that we've looked at a variety of different options, including that. But speaking directly to your question, so if we're going to get to Mars anytime in the next 20 years, I think it will be chemical propulsion. Sometime out in the future, it may be a different way. It may be nuclear propulsion or ion propulsion. We've talked about other things. We're just not far enough along yet for that to be sort of the near-term way of thinking about it. So if you're thinking about chemical propulsion, so we have the SLS rocket under development at NASA, and then other companies like SpaceX are also talking about and working on heavy lift rockets as well. It really is important to have a heavy lift rocket, because otherwise it takes so many launches to get the, what you need to get into space to actually get to Mars and to have the supplies, that it becomes just a hugely operationally complex problem. And so heavy lift is really important. But to me, it's important to think about the combination of the rocket and the spacecraft that you will need.
Right.
And Orion, which is the one that we're developing now, will get you into space and get you back to Earth, but you also need a deep space habitation module that will allow you to stay alive for the long time of the mission.
You might have multiple energy systems because you have to lift.
Right.
That's the hard part. But you could have the Cassini, but it's a whole different size.
Yes.
But it was nuclear propulsion, and so you need an energy source.
Yeah, absolutely.
And so all of those while you're going along, and then people make use of the physics, which has to do with where there are points. They're called Lagrange points, where you have a kind of a balancing of gravitational forces. And so all of that is part of it, and it plays into what kind of propulsion systems. But I think you can have multiple types of propulsions depending upon the stage of the journey.
Yeah.
Other questions? Yes. Right there. Keep your hand up till the mic runner finds you. Thanks.
So I don't know if you guys have ever either played it or heard of it before, but I was wondering, especially in terms of just educational value and getting people interested in either space exploration or similar STEM fields, if you guys have either heard of or either played Kerbal Space Program, and what your thoughts just on that sort of either collaborating with stuff like that, to have people thinking about these complex problems, just what your thoughts about the program are.
Which program is that?
Kerbal Space Program.
Kerbal.
It's a computer game, simulates.
Anybody with?
Well, I've never played it, but I am one who believes that gamification is a pedagogical tool if it's set up the right way. So maybe I should take a look at that.
There we go. Other questions? Yes, right here in the center. Side by side, right in the middle. Keep your hand up until we have a mic in it. There we go, thanks. Here it comes.
Wave propagation.
Hi, thank you for coming. My question is to ask you all what you think our generation's role is in the next coming years to make this mission possible. You have all laid the foundation for what we will hopefully be accomplishing, and so it'd be good for us to have some insight on what you think the next steps for us to step up to are.
So what's the role of this generation?
Well, you're going to make it happen.
There you go.
Okay? You are going to make it happen. So you're going to play a huge role. And I think we've all touched on, there's so many different areas that we want to work on and understand more to go. So some of it is the human risks that we talked about. Some of it's the systems engineering and the regenerative life support. We're already using systems on the International Space Station where we recycle air and we recycle water. We're actually recycling urine. So as some of our astronauts like to say, we turn yesterday's coffee into today's coffee. But right now we recycle about 85% of the water, and we need to get to 95% or higher. And those can be used. You talked about how solutions like that are being used on Earth, and in fact, there are rural communities that are using the processes that we have developed on ISS. So there's that whole aspect of it as well. And then, we've got 3D printers on orbit now. We have a DNA sequencer. So, all of these things that we didn't used to think about that are now changing our model of how we might actually get to Mars. A whole bunch of different areas.
I would answer it a different. It's a complementary way, which is, if you're in science and engineering, I hope that many of you stay in it, and that you work to be as good as you can be, and that you really pursue your passion. Because in the end, it's going to be a range of technologies and a range of breakthroughs that will be needed. We can't be totally predictive of what they're going to be sitting here today. We know the types of problems that you have to face, and then go work for NASA.
I'll answer the question a little differently, and I think the role of all of you is really innovation.
That's right.
Okay, we need you people in your positions to just start thinking about what's out there or what's not out there that we really need, and what can we do differently. Let's take a current day example. Did anybody ever think when the internet started that it would have the impact on the world that it does now? We now have an app-based business model, all right? Those are things that never existed before. I'd be willing to bet that there's a large percentage of the students sitting in this room that are going to be doing jobs that haven't even been created yet. Okay, so you need to start thinking about the innovation side of it. And, we talk about STEM, but there's a lot of people that add that A to it, the art, right? There's two parts of our brain, and one of them is going to allow, we talked about this earlier, the dreaming, right? What is it, and we have to work together on creating, a different mindset about, it's the art of the possible. And, I think that could be one of the biggest areas that you could help in.
So what I hope this millennial generation will do is find its voice early. Because in so many ways, so my father's generation was called the greatest generation. They prosecuted the Second World War successfully, defending our species against fascism. They lived through the Great Depression and brought this country to a level of greatness, the likes of which I don't think the world has ever seen. My generation, which came after, I sometimes refer to us as the greatest slacker generation. Because
speak for yourself.
As I
Professor,
did say,
student.
But so, my generation, I look at the legacy that we're leaving behind, and yeah, we've done great things like invent the internet and what have you, but the array of problems that these young people will be facing is just, to me, just dazzling. And so my plea to this generation is to begin the process of knitting back together our society around the belief that the American dream is for everybody. I think that's the most important thing that this generation could do.
Question? Yes, right here in the center. Yeah, do we have a...
He's got a mic already.
So first of all, thank you all for coming. I had a question about the public versus private partnerships that are going on. So you guys talked about that a little bit. Is there a point where there'll need to be some kind of a balance between scientific interests and business interests in the future if the status quo shifts toward more of the private side of that? Is that something NASA has thought about at all, or is that something that we need to be thinking about for the future?
So the question is business versus government. Is there a balance there that will have to be regulated or thought about in some way, or is it self-correcting?
Well, I'll answer, but of course everybody should feel free to chime in. So I think for a long time anyway, and hopefully a very long time, there is a role for NASA, a role for a government agency that looks to what can the country as a whole gain from having a space program. And you can talk about, global leadership, you can talk about economic benefits, expanding scientific knowledge. So there's a variety of things that by having a government program, the benefits really accrue to the people here. What we have tried to do as we've moved out into these other models of partnerships is to say, other people's goals may be a little bit different, but let's figure out how our partners can achieve their goals while we work with them to achieve our goals. And that's a big role that I think NASA plays, is trying to figure out, like we're designing this infrastructure. I say we, I'm retired from NASA now, so I should just probably make it clear I don't speak for NASA anymore, but I'm still pretty familiar with what they're doing. So we're designing this infrastructure to be in orbit around the moon called the Gateway. And so it'll have international cooperation, public-private partnerships with a variety of different industries here. Everybody's going to have a little bit different goal, but I think NASA's role is to coordinate and to ensure that we have the infrastructure so that the partners get what they want out of it, and we are moving forward our vision, which is eventually to get to Mars and hopefully beyond, but Mars is kind of the horizon goal. And so that's what I really see NASA's role as.
Tom, do you want to weigh in on that?
No, I'm good.
Yes, next question?
I'm sorry. I would like to comment about that because I want to make sure that people have a fundamental understanding. Earlier, Dr. Jackson talked about a three-legged stool of government, business, and universities, right? Yeah. And I think that there is not a deep understanding of how this triumvirate has actually worked in the past. And the internet is a perfect example of that. Most people are not aware that we would not have an internet if it weren't for a small piece of the government whose name has changed several times, and sometimes it's called DARPA, sometimes it's called ARPA, but there's a small agency in the government that was, in the words of one of our reports, the foundational investor in this technology, which then grew to take over the world in some level. And so the point is that we have, over the course of the last century or so in this country, been the beneficiaries of a kind of partnership that everyone has perhaps not understood was operative. Most people think the internet came from some large corporation. It really didn't, folks. It actually came from the government. And
well, it's even more, it even is as more fundamental than that. If you didn't have the global positioning satellite system, you could forget the whole thing. Mm-hmm. But I'm one who says in the end, you got to look at how it's all connected, right? And if we shut down the electrical grid, we also wouldn't have an internet.
So that's correct.
The question, I'm sorry.
Yeah, but the point being, and I think this is what we're trying to say, that we have to have an understanding of what's the public good. And there are things that government does and can do. Sometimes it's done in the name of defense. Sometimes it's done in the name of disease mitigation. Sometimes it's done in the name of fundamental infrastructure. But there are a lot of technologies. Jim mentioned DARPA, but you have your GPS system, you have encryption, there's so many things that when you're playing around with your device that you have no idea, most people you do, of what is really behind it. And it didn't just spring forward willy-nilly from industry, but many times it was a partnership, a public-private partnership. But a lot of it came from fundamental government investment in certain kinds of systems and infrastructure, and as well as the investment in human capital, and that's important.
Question over here, right there in the green. Oh, I'm sorry, that's good. One after the other.
I had a question for you about competition versus cooperation. So considering the competitive nature that has driven all these technological advances as a species, do you think this is what will drive us to Mars, or do you think that's a detriment and that cooperation is what will get us there?
Competition or cooperation? Who wants to?
I mentioned it earlier that I can tell you that right now there's plenty of competition going on. If you look at the commercial enterprises that are launching into space versus, as I call them, the industrial military complex, traditional people that we think of, there's a tremendous competition going on. But I think they're going to be forced into a cooperative environment. There's just not enough money to do it. And that's why, I feel, pretty strongly that, that they're going to have to join forces and quit beating each other up.
And let me just add that it's not just around going to Mars. This is a trend that we see especially in big science, that if we're going to continue as a species to push the boundaries of science the way that we have in the last century or so, it's going to have to be cooperative. It's going to have to be internationally cooperative based, because no one nation basically is going to have the resources to do it. So there's a lot of things forcing us towards cooperation.
And also, there's a lot of work that has to be done in some unique new fields. Dr. Ochoa mentioned propulsion, and you have SpaceX, but it's not clear that that's what they use and do is a leapfrog in terms of propulsion systems. And so there has to be, some broader collaborative thing that occurs.
Let's stay right over here.
So you guys have talked a lot about getting there. What happens after we get there? we make it there to Mars. We do all of our preliminary science, kind of figure out the geology of it. Do we stay? Do we, try to colonize? Is that even worth the time?
Well, if I may jump in.
Yeah.
One of the things that I have said over long duration is that an investment in science is actually an insurance policy for our species. And I would hope that at some point we would establish permanent residences for our species, because there are these things out there that are called planet-killing meteors. And it would be nice to hope that we take out this insurance policy, that the species doesn't get to experience one of these extinctors.
You know what I actually say? You're actually going to be the one who's going to answer that question, because you are going to be part of the generation that are going to help people to get there. And it's going to be somebody who's probably your little baby brother, and I mean really baby brother, who'll be the one to go. And so it is an important question. But actually, interestingly enough, it's going to fall more on you.
Time for here, right in the middle. In the gray, next to the green. Here we go. I'm reading light. Okay.
Hi. Is this work? Okay. So my question is.
Can you speak up?
Speak up. Okay. So my question is, before we focus on working our way over to Mars, why haven't we tried to focus on populating the moon per se first?
So the question of Mars or the moon, which is a real question, who would like to?
I'll take a stab at that, and then Dr. Ochoa, I'm sure, will correct me. But
I don't think there's a correct answer. There's just different.
So. I've actually thought about this because if you look at NASA's plan, they have, a 5 or 6 phase plan. The first part is experimentation on the International Space Station. And then there's launch 6 SLSs and Orion packages to work on that. And then you go into the deep space transport so there's all these different phases. My biggest concern is, we need to practice around the moon and on the moon, but I think it would be a mistake for us to become enamored with the moon again. Okay, it's a necessary part of the phasing to get to Mars, but my concern is that we'll get back to the moon and fall in love with it again and think we're all Neil Armstrong and we're going to start doing moon things again. And it's something I think we all, part of exploration is wonder and opportunity. I mean, the original astronomers saw Mars and thought it was, a destination of intent. And that destination of intent is all about wonder and opportunity. So I think the further we go and the more we push ourselves, as a human race, to challenge ourselves technologically, it'll benefit us even more. That's my take.
Admiral, I like that, the destination of intent. It's very important.
We've got time for one more question, right down here. Yeah.
Hopefully this isn't too silly of a note to wrap up on, but you mentioned that Mars had a magnetic field and therefore an atmosphere and therefore water. Is it possible, and it's probably not within the scope of our, of what is reasonable, but can we somehow restore the magnetic field to Mars, or is that just not a thing that happens?
Well, people have talked about terraforming Mars for a long period of time, but it's actually not clear how you would actually do that, yeah. Particularly in the in the time frame that any of us might be talking about here. That's but right. I'd be happy to hear from anyone else on the planet.
Terraforming is, as you probably know already, is the transformation of the surface of the planet. But the turning on of the magnetic field is something that we don't even understand very well. The geomagnet. We have a magnetic field here. We don't have a deep physics understanding of how our own magnetic field gets turned on. So that would make it really difficult to turn on somebody else's.
Well, I think, you know, Professor Gates is totally correct. And there is this interesting interplay between what happens with the sun and what happens here. And we don't totally understand how the whole, as I said, magnetohydrodynamic thing works and how it affects, you know, the magnetic fields here.
And I think that's actually really exciting. There are so many things we don't understand, and there's all these areas of research which are absolutely just ripe for people to learn more about. So, you know, maybe one of the last comments I'll make is just, this is a really, really exciting time in space exploration. There's these fundamental physics questions about our solar system. In human space exploration, there are more vehicles under development now than ever in our history, in anybody's history. And so it's just a hugely exciting time to be thinking about space exploration and to be working in space exploration.
Would any of the rest of you like to make a closing comment then?
Yours is the new space age, except it's not about the moon. It is about Mars. But it also is an opportunity to do what is the best in humanity. And that's how we come together to address great challenges. And you have the opportunity to do that. You come from all over this planet, and you're brought together in a unique place and time. And so I would just hope you would seize the moment. And then if I can digress, I do want to recognize our mayor, the Honorable Pat Madden, who's joined us today, who also happens to be a Rensselaer alum.
Very good. So I want to thank, would you like to?
Well, my comment is just that I have absolute, complete confidence that this new generation, that they're going to do better than we did. And so all I can say is just do it, like a certain commercial.
I guess my message is no endeavor that of any type that we take as humans is without risk. It's how you deal with risk and you know, how you mitigate the risks. But I don't know how many of you know what Winston Churchill said about success. And it's the ability to take a series of failures with no less enthusiasm. Okay?
Winston Churchill also said, stay calm and carry on.
Very good. I want to thank all of our panelists for their contributions tonight. Thank Rensselaer for their contribution, the National Science and Technology Medals Foundation, and thank you all for giving of your time and for having such good and interesting questions. We're going to retire to Evelyn's Cafe, so please join us there for a short reception, and see you in a moment.
Thank you.
Thank you. Thank you. Thanks very much. Thank you, sir.